A very warm welcome to WsCube Tech. So guys, in our previous session, we have covered some functions related to our Numpy arrays. In our today's session, we'll be covering more functions. These functions are power, difference, cross, and sort. We will first understand how these functions are used, then we will be applying these methods inside our PyCharm to understand that how these functions actually work. The first function we have over here is power. It is used to get a power of an element. Suppose if you have an array that is namely 1, 2, 3, and 4, and if you want to give a power to it, in that case power function is used. Suppose if you want to give a power to every element that is there inside this array, so if you want to give a power of 2 to every element, what you will obtain over here would be 1 raised to the power 2 would be 1, 2 raised to the power 2 would be 4, 3 raised to the power 2 would be 9, and 4 raised to the power 2 would be 16. So this is how you can obtain an output over here using the power function. Moving ahead, talking about our next function, that is difference. This function is used when we calculate the nth order discrete difference along the given axis. That means what happens over here, suppose if you have an array like this, you have 1, 2, 3, and 8. Okay, and if you apply the difference method over here, the first element would remain the same. The second element would be the subtraction in this way, that this element minus this element, that means 2 minus 1, that would give us 1. The third element would be the subtraction of third element minus the second element, that would be 3 minus 2, that is 1 again, and 8 minus 3 would be 5. This is what we will basically obtain if we use a different function. Similarly, if I talk about the cross function over here, the cross function will give you the cross product. Now, how to get a cross product over here is very simple. Suppose if we have two arrays in this way, we have 1, 2, 4 and 6 here. Okay. Now, cross product means that we will be multiplying them in this way, that 1 multiplied by 6. So 1 multiplied by 6 would be 6 here, and 4 multiplied by 2 would be 8. So the output over here would be 6 minus 8, that is minus 2. So this is what cross product will give us. Lastly, we have the sort function. Sort function will give us the sorted copy of an array. That means if you have 1, 8, 6, 3. Then after sorting it in ascending order, it would give us 1, 3, 6 and 8. So this is how the sort function works over here. Let's see its practical explanation as well. First of all, let's start with the power function. To use the power function, first of all, we will import numpy. So import numpy as np. Once we have imported numpy as np, we'll be creating two arrays over here, or if we are working on a power function, we only need one array here. So I'll be writing arr is equals to np dot array, and I'll be writing some elements. For example, we have 1, 2, 3 and 4. If I print it, so print arr, I'll get the output as 1, 2, 3 and 4. Now suppose if I want to provide it with a power, for that I'll be creating p. So p is equals to np dot power. For inside the power, we'll be giving two parameters here. The first parameter is that on which array we want to apply it. So we'll be applying it on arr. So I'll be writing arr here. And the second parameter is what power we need to apply. So suppose I want the power of all of them as 2. So I'll be giving a square bracket. That means in the format of a list, I'll pass 2 here. As soon as we'll run it, we don't need to run it. First of all, we need to print it. So for that, I'll write print. So this one should go over here, and I'll be writing print and p. As soon as we run it, we'll get the output in this way, that we have first element as 1, because 1 raised to the power 2 will give us 1 only. 2 raised to the power 2 will give us 4, 3 raised to the power will give us 9, and 4 raised to the power 2 will give us 16. Similarly, if you want to change it to anything else, suppose if you want to give the power as 3, in that case you just need to write 3, and on the same array it will give the power of 3. That means 1 raised to the power 3 is 1, 2 raised to the power 3 is 8, 3 raised to the power 3 is 27, and 4 raised to the power 3 is 64. Similarly, if you want to provide with different powers for all of them, in that case what you can do, the number of elements are 4 over here, so you can give 4 different powers. That 1 raised to the power, I will just give 1. For 2, I want the power as 3. For 3, I want the power as 3 again, and for 4, I want the power as 2. So if I run it, I'll get the output in this way, that 1 raised to the power 1 is 1. 2 raised to the power 3 is 8, 3 raised to the power 3 is 27, and 4 raised to the power 2 is 16 here. So you can give different powers for the different elements inside the array as well. This is how a power function works. All you need to do is create a variable over here. Inside this, you can pass np dot power. You can pass the first parameter as the array, the name of the array on which you want to apply this power. You can give a single element if you want to apply the same power on all of them, and you can give with the multiple elements. Just remember that the length of your array should be equal to the number of powers that you are giving over here. So this would be our first function. Now let's move ahead and talk about our second function, which is difference. So for that, I'll be creating two arrays here. So arr is equals to np dot array, and inside this I'll be passing 4 elements. So I'll be writing 1, 5, 8, 3. and another array I'm creating. So arr1 is equals to np.array, and here again I'll be passing a list, that is 2, 7, 3, 5. Or you can work with a single one element as well, but as of now, first of all, let's talk about the first element as well, like first row over here as well. So I'll be writing, first of all, for difference, I'll be writing d is equals to np.difference, and inside the difference, I'll be passing arr. So let's run and see what output we'll get. And after this, I'll print d as well. Now let's run and see what output we'll get. So as soon as I'll run it, I'll get the output 4, 3 and -5. And similarly, if we'll do it for our second array, so second array will give us an output like this, that we will not receive the first element, that means we will not obtain the first element. But what we will obtain, 7 minus 2 would be 5, the first element would be 5, the second element would be 3 minus 7, that would be -4, and the third element over here would be 5 minus 3, that is 2. So if I do it for arr1, we will be obtaining 5 minus 4 and 2. That means 7 minus 2 is 5, 3 minus 7 is -4 and 5 minus 3 is 2. So this is how difference work over here. You can do it along the axis as well. For example, you can give over here in the format of an array arr, arr1 in the form of a tuple. So I'll be putting a tuple over here. I'll be creating a tuple basically here. Here we can put a comma and give axis is equals to 0. So that would be our vertical axis. And as soon as I run it, I'll get the output that 2 minus 1 is 1. 7 minus 5 is 2. 3 minus 8 is 5, minus 5. And 5 minus 3 is 2. So this is how we can do it along the axis as well. Similarly, if I talk about cross over here, let me just remove 2 elements from here. So I'll be removing these 2 elements, and from here I'll be again removing 2 elements. So cross product would be 7 minus 5 times 2 is 10. So 7 minus 10, that would be -3. So for that I'll be writing C is equals to np.cross. Here I'll be passing 2 elements, that is arr, arr1. And as soon as we run it, we'll get the output. Nothing, because we haven't printed it yet. So we just need to print it. So print C. And now again, as soon as I run it, I'll get the output -3. Why? Because 7 multiplied by 1, cross product would go like this. So 7 multiplied by 1 is 7 and 5 multiplied by 2 is 10. So 7 minus 10 would be -3 over here. This is how cross multiplication works. While at the same time, if I talk about the last function over here, that is sorted, to sort a array over here, I'll just put this one also inside it, or we can use both of them as well. So I will show it to you along the axis as well. So I'll be writing 4 and 1. So 1 we have used already, so I'll be using 2, and I'll put a comma, write 4, 2. Or 2 we have used already, so I'll be putting 5. Okay, once we're done with this, we will be writing. So we are sorting over here. So S is equals to np.sort, and here inside the sort I'll be passing arr, arr1, and we can pass it inside a tuple so that we can give the axis as well. So I put comma and axis is equals to. So I want to do it first vertically, and as soon as I run it, I'll get the output nothing, because again we have not printed it. So let's just print it first. So I'll be writing print S. And now if we run it, so we'll be getting the output vertically now. So here I'll just change some elements to bigger elements, so that now if I run it, I'll get the output in this way, that we have in the first two elements, if I talk about the first elements of both the rows. So let me just print them as well. So I'll just write print arr and print arr1, and if I run it, I'll get the output like this. So if I talk about the first 2 elements over here, in the first 2 elements, that means if I talk about this right now, first elements of both the rows, here 1 is smaller, so 1 came first and then 2. In 7 and 9 is bigger, that's why 9 is coming in the second row and 7 is coming in the first row. In the third row, both 4 are there, so nothing will change here. In the fourth column over here of both the rows, we have 2 and 5, so 2 is smaller over here, so 2 remains here and 5 comes in the second row. That means we are right now sorting it vertically. If I talk about horizontal axis. Now next, if I want to sort it into horizontal axis, in that case I'll write x is equals to 1, and as soon as I run it, I'll get the output 1, 2, 4, 9. That means we had 1, 9, 4, 2, 2, 7, 4, 5. So we'll be writing 1, 2, 4, 9. We will be obtaining 1, 2, 4, 9. That means if I sort it horizontally, I'll get the output in the ascending order 1, 2, 4, 9. And here in the second one, we'll obtain 2, 4, 5 and 7. So this is how our sort works. So I hope guys that all the functions over here are clear to you. Our first function is called as power function, where we can give a power to all the elements inside the array. Second function is difference, where we can obtain the difference of the arrays. Inside it, we can go with the axis as well, that if you want to find the difference horizontally or vertically. Similarly, cross works over here. Cross will give you a cross product. And lastly, we have sort. Sort can be used in both the axes, that means in the y-axis and the x-axis. That means you can go horizontally and vertically as well. So I hope guys that all the functions are clear to you and you have no doubts in the questions. In our next session, we'll be talking about more functions. So stay connected guys, and I'll see you in the next session. Thank you.